here, I've got a matrix that has in this first column 1, y, and 3, x, 5, and 4 in the second column. I'm telling you that that is equal to matrix that has 1, 8, and z in the first column, and 2, 5, and w in the second column. Alright, so before I read to you what the problem actually asks us to do, which you probably already got figured out, we got to talk about dimensions of matrices. We did a little bit yesterday when we typed them in our calculator. We had to know how to change that matrix on that beginning screen, that dimension. These are both 1, 2, 3 by 1, 2. Both of those are 3 by 2s. Excuse me, because something's in my throat. The first number is the rows. That's horizontal. That's how you plant your garden. The second number is the columns. That's vertical. That's what supports your house. Rows by columns. That's pretty important to today's lesson. We're going to have to use that a lot when we get into all of this stuff today. Okay? For this problem, though, they're the same. We got a 3 by 2 and a 3 by 2, right? So I told you they're equal because they got an equal sign in there. So here's what the question says. For what values of the variables is the following matrix true? So for what values of the variables would that be true? Would that be equal? Well, since it tells you they're equal, this is baby stuff right here. The same spots have to be equal. So top left, that's obvious. 1 equals 1, right? So x is good. X is in the top right, so it has to equal the top right. So x would have to be 2. Pretty simple stuff on this. Y is in the middle left, so it equals the middle left, which would be 8. And that's all the ones I got there. Let's come over here. Z is in the bottom left, so it equals the bottom left, which would be 3. W is in the bottom right, so it equals the bottom right, which would be 4. So pretty simple on that. Just matching spots, right? We can all match spots. I hope so. We're in trouble if we can't.
It gets harder.
Not too much, not too much. Okay, now, easy there, killer. Now I've got, I'm going to do some addition and subtraction now. I've got 2, 4, 3, 6, plus -2, 3, 5, -1. Alright, when we had an equal sign in between them on the previous problem, the corresponding spots were equal. This time I got a plus sign between them. So what do you think we're going to add?
The corresponding spots.
Very good, Hayden. You're going to add the corresponding spots. So I'm going to look at this. I'm going to say, well, my answer is going to be in a matrix. Top left plus top left. 2 plus 7, 2, 0. Good, Chase. And I'll put that in the top left. You put it where it came from. You're not going to add top left, and then put it in the bottom right. Okay, put it where it came from. You can go in any order you want. So if I want to go top right now, 3 plus 5 will go in the top right.
Approximately 8. Actually, it's 8.
Approximately, yes. Bottom left, 4 plus 3 goes in the bottom left.
7.
That boy. In the bottom right, 6 and -1. So that would be your answer. That's all you have to do on that. You're just adding corresponding spots, like Hayden said. What if though?
I used big words.
You did. I was proud of you. What if though it said the same one on the left, 2, 4, 3, 6 plus 0, 8, 5, 7. What if we had that? 2, 4, 3, 6 plus 0, 8, 5, 7. And we're told to add that.
Ooh.
And on the first one, we added corresponding spots.
And zeros in this one.
And just add spots to those.
Okay, check this, what I'm writing here out, Baylor. Can't simplify. D-L-I.
You were close, dude.
Yeah.
Good
Right.
job.
Alright, so here's the rule. When you're adding and subtracting, because our rule's going to be different when we go to multiply in a second. When we're adding and subtracting matrices, the dimensions have to be the same. You can't add and subtract if the dimensions aren't the same. So in this first one we did, that was a 2 by 2 and a 2 by 2. That's the same. Here I had a 2 by 2. What's the dimensions of this thing?
That's a 1 by 4.
Yes, it is. Good job, Zane. So they're not the same, so you can't add them. junior girls, JV high school, and senior varsity high school. Yes, ma'am. Thank you. Same dimensions to add and subtract. So let's look at a subtraction one right quick. Alright, so first question to you is there's a subtraction sign between those, so can I subtract them? Is it even possible?
I'm going to take a wild guess and say yes.
Hayden is correct on this wild guess because they're same dimensions. Okay, those are both 2 by 3s, right?
Mm-hmm.
See that? So we can subtract. So all we're going to do is subtract corresponding spots. So go ahead and do that for me real quick. Your answer, both of those matrices are 2 by 3s. So your answer matrix will also be a 2 by 3. Go ahead and subtract those real fast.
Okay, well, hold on a minute. Like, if I'm putting a 9 with a -2, it's going to be
11.
It called me stupid. I think I have.
Do what?
That's
cool.
Did I?
Oh my gosh.
That really hurt it.
Alright, we got top row. Tell me all three in the top row.
-5 over 5.
They ain't said, never have a little bump. Everybody get that?
Yeah.
Everybody good on the top row?
Yep.
Alright, what we got on the bottom row?
So slow at this.
Say it again, Grace. 1, -5, -5. Everybody good? Alright. Could you subtract matrices in your calculators? Yes. You could add and subtract them in your calculator. You would do like we did yesterday. You would hit alpha zoom and then change your dimensions and type your numbers in there. That would work. Something this simple, Mason, y'all simmer down. Something this simple, I think you ought to be able to just do that faster than you can type it in the calculator. When we get to multiplication, though, they get a little bit more involved, and I might use the calculator on some of those. Alright, but you could. I had people first period that were adding and subtracting them with their calculator, so you could. Alright. This next thing we got here, a form of multiplication. I got 2/3, and then I got 18/9 in column 1, and 24/12 in column 2. Okay, so we got 2/3 stuck right outside that matrix. Just like normal math, what does it mean when you got a number stuck right outside something?
Multiply.
Good. You're going to multiply, you're going to distribute it to everything in. That's exactly right. Mason, pay attention. So, same thing here. Now, I don't know where this comes from, where the term comes from, but they call this with matrix, when there's something stuck out in front to multiply, they call that scalar multiplication. Scalar multiplication. I don't know what scalar means to know why that's the name of it, but it just means, like y'all said, we're going to distribute it to everything inside. So, I would have here, these are, people are like, oh great, we got a fraction, but these are all multiples of 3, so these are easy to multiply. I'm going to do a quick fraction review for you. 2/3 times 18. 18 over 3 is 6, so that's just 2 times 6. 24 times 2/3. 24 over 3 is 8, so that's just 8 times 2. 2/3 times 9. 9 over 3 is 3, so that's just 3 times 2. And then 2/3 times 12. 12 over 3 is 4, so that's just 4 times 2. Okay. So easy on the scalar multiplication. That's still something I would just do by hand. Now, when I say that by hand, that doesn't mean if you don't know what 2/3 times 18 is that you can't type that in the calculator, because you can, that's fine, even though that bugs me. But I'm saying I wouldn't enter the whole matrix, you know what I mean? When I get to some bigger ones, like a matrix times a matrix in a second, then I'll go ahead and enter that in matrix form. Okay, y'all all right on that? All right, let's look at doing some matrix multiplication now. Where'd that one go that I did first period? That was in front of there it is. All right, let's look here. I've got 1, 7, -3, 2. And that's right next to a matrix that has 1, 3, 0, 1, -1, 4, and 2, -1. All right, first off, what does it mean when a matrix is right next to a matrix? They're being multiplied. Very good thing. This is not addition or subtraction. If it were addition or subtraction, I would not be able to do it because they're not the same dimensions.
Can you divide that?
Mm-mm.
You can't?
So what we're looking at to decide if it's possible to multiply, it has to do with the dimensions again. So what is this first matrix? What's its dimensions? How big is it?
2 and 4.
No.
2 and 2.
2 by 2. Now this one's the one Zane was talking about. This one is a 2 by 4. So to decide if it's possible to multiply, after you write your dimensions there, yes, sir, that's all right. Oh, don't worry. You just pulled it off. About. No, don't shoot me on that. Yeah. Okay. Okay. Sounds good. Well, I mean, you never know with a tournament thrown in how many that could change it, but right. 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 Yeah. Yeah. Right. Okay. Sounds good to me. People like that. Oh no, that's selfish. Okay. So that's well. So that's what I'm not going to ask to help me. No, I doubt it. Yeah. All right. Well, okay. I can start in the morning. We got a game. What time do I need to leave? Yeah. Sounds good. I'll be there. Thank you much. Bye-bye. I need to shake for a while now after that. Okay. We got a 2 by 2. This was important before we got interrupted on these dimension things because this is how you decide if you can multiply or not. You got a 2 by 2 and a 2 by 4. When you see how I wrote them back to back like that?
All right.
Yes. I'm thinking we're going to try to leave at 1:30, and I'm going to get them in at 1, and then so we leave as close to 1:30 as possible. Okay. Okay, sounds good. Thanks, bye. Anyway, math class. Now my thing's been working. I've got the middle ones. That was the reason I wrote that back to back. To see if this is possible, Mason, those middle ones that I just underlined there, those have to be the same. In this case it is. So it's good. This is possible to multiply. 2 and 2 is the same. Then what size will my answer be? The outside numbers tell you that. So my answer will be a 2 by 4 matrix. Okay, so if the middle ones are the same, you're good to go, and your answer will be the outside matrix. Alright? So, you be ready? I'm going to show you how to do this one by hand, and then after that, I'm probably going to do them all on the calculator, but I am going to show you by hand once, because I need to. I don't want you to think that the only way to do this is in the calculator. So can I erase? I'm going to have to go right there. This thing's acting up. Can I erase that sort? Because it's going to take a lot of room to do it by hand. Y'all got those dimensions written down like we need them? Alright, what we're going to do when we're multiplying these, I'm going to take the first row and I'm going to multiply it by each column. Then I'll come back and pick up the second row and multiply it by each column. So this is going to be, I'm going to have to try to scrunch a bunch of stuff in. I'm going to have 1 times 1 plus -3 times 3. Okay, and I'll simplify all that later, but I just want you to see what the process is, how you make sure you get everything multiplied by each other. So first one, like that. Okay, so now I'm going to do the same thing with these and this one. So I'm going to skip a little space, and I'm going to have 1 times 0 plus -3 times 1. Okay, now I've got to do that same thing with the third column. So I'm going to have 1 times -1 plus -3 times 4. Okay, then I got to go one more time to the last one. 1 times 2 plus -3 times -1. Okay, so we've taken that first row to all of those. Now we got to come do the same with the second row, but here's the easy thing for me. Everywhere in the first row where I have a 1 and -3, a 1 and -3, a 1 and -3, 1 and -3, it's going to be 7 and 2, right? So I'm going to have 7 times 1 plus 2 times 3. 7 times 0 plus 2 times 1. The zeros, this stuff is the same. I'm just changing out the 1 and the -3 with the 7 and a 2, right? So here will be 7 times that -1 plus 2 times that 4. 7 times that 2 plus 2 times that -1. Alright, just some basic easy math to finish this up now. This is 1 plus -9. 0 plus -3. -1 plus -12. 2 plus 3. 7 plus 6. 0 plus 2. -7 plus 8. 14 plus -2. That's your answer. That one wasn't really all that bad. That was 2 by 2 times a 2 by 4. 2 by 2s times 2 by 2s, those are easy. Once it starts, like I've had 3 by 3s times 3 by 3s, 4 by 4s times 4 by 4s, I do that in the calculator, because that ends up being lots of stuff all throughout the process. So all you would do to do this in your calculator, you hit alpha zoom, 2 by 2, enter your numbers, times alpha zoom, 2 by 4, enter your numbers. It does that for you there also. So you could do that either way. Somebody lose their dryer sheet.
Yeah.
Random dryer sheet. Sometimes that happens to me. Falls out of her pants leg or something. Alright. I'm going to let you try one. You can do it either by hand or on the calculator, either one. Do an easy one to start with. Alright, I got negative 1, 1, 3, 2. I want you to multiply that by 3, 1, 6, 5. Alright, see if you can get that one figured out. Go. Should I do it in the calculator or should I do it by hand? Calculator. So if I'm doing it by hand, I'll be here so far. Then to finish this off, catch up with y'all, this will be negative 3 plus 3. Should I get 0 on the top left? Negative 6 plus 15, that's 9, I think. 3 plus 2. And 6 plus 10. Did I get it right?
Yeah, that's what I heard.
Good. Good deal. Good deal. All right, I got one more problem for you. So good job. Get that one finished up, and I just got one more.
Is it our exit question?
No, I toyed with an exit question first period, and matrices are too hard. Matrices are too hard to type. All right, we good? I got it.
Yep.
All right, I'm gonna label some stuff and try to make you make a connection here. Matrix A has negative 2, 0 in column 1 and 4, 3 in column 2. Matrix B has alright, so there's what I'm giving you. Here's what I want you to find. Would you look at me like that, Caitlin? You can do it.
No, he was a secret. You weren't supposed to tell him.
Is that the song? That is the song. That or there's the song.
This?
Yes.
No, this is what I made.
Like the song.
Search it up. Those are all my words.
I feel like it's a song.
I'm gonna shoot some. It's just because we listened to Ric Flair.
Yeah, dude.
Alright, what would be the first thing you would need to do?
Times A by 2.
Very good. Y'all listening? Shh. Zane's correct. The first thing we need to do is double A, which I told you a funny name for that. What was that called? Start with an S. Scalar. Good, Mason. So I'm going to take 2 and I'm going to scalar multiply here. So that would be negative 4086. Now, have I satisfied that part? Yeah, so now all I do need to do is subtract the B. Very good. So you could type, 2 times that minus that in your calculator, but it's,
Like that?
yeah, that should get us the same answer, Mason. Good. So negative 4 minus negative 6, what do I have in top left? 2. 0 minus 4, bottom left. Am I good so far, Mason? With what your calculator said? 8 minus 2, top right. And then bottom right, 6 minus 0.
Yeah.
Is that what yours had, Mason? Just check and make sure you got it typed in right. Everybody else get that also? Okay, good job. You could see some of these where in a spot in the matrix there's an equation. Like this one could say x plus 3, and this one could say 2, and you have to solve it that way as well. But we'll review over that if we need to later. All right, everybody feel confident on matrices stuff so far?
Yep.
It's pretty easy. People say that they see these on the ACT and don't know what to do, but it's like just common sense kind of stuff.
Yeah,
Yeah.
we just made
Yeah.
100 on it now.